Okay, chapter 3 is going to start talking about the rock cycle. I'm going to split this chapter into two pieces because the schedule has chapter 3 split into two different days. Just a quick overview about this chapter. It's going to talk about the different types of rock that occur in the rock cycle. Um, it's kind of a dry material, and there's not much I'm really going to add to many of these slides. It's just a lot of material that you have to absorb. So just make sure you're reading the book for this chapter. All right, so the rock cycle. We're about to see probably one of the most confusing diagrams ever. So this is just a slide showing you Earth as a system and one possible uh, process for rocks to change. So you could have rocks starting as magma and then changing into igneous rock and then forming a sediment, which then layers, which is what lithification means, and then changes into sedimentary rock, and then that rock is metamorphosized by pressure and temperatures to change into metamorphic rock, and then it can melt and then go back to magma. So that's just one possible uh, method for rock to change through all the different types of rock. So this chapter is going to go through igneous rocks, sedimentary rock, and then metamorphic rock. So here's that insane diagram. Sometimes I think textbooks just like to make diagrams. I'm not going to be super concerned with you knowing every single direction that something can change into, but just know that essentially any type of rock can then change into another type. What I'm primarily going to be concerned about in terms of quizzes and exams will be the purple arrows that you see here. So if you start as magma, you would then cool and crystallize to form some type of igneous rock, and then there would be some other processes that would work on you to form a sediment, and that sediment would then change into sedimentary rock, and that rock could be formed by pressure and temperature into metamorphic rock, and then the cycle can just repeat itself. So just make sure that you understand that basic idea for this rock cycle. Okay, igneous rocks. Like I said, I'm not going to add too much to these slides. Just know that you're going to start as magma, it's going to cool and crystallize, and then form a type of igneous rock. Now, there are various forms of igneous rock, and there's all different types of textures. So there's going to be pictures on the next few slides that kind of show all the different types of rock. Now, on the quizzes and exams, you're not going to be shown pictures of these rocks, but you are going to have to know what these words mean. So just make sure that you understand these vocab words and you'll be fine for the exam. So this is an example of fine-grained igneous texture. So if you were to touch this, it would kind of feel like sandpaper. Coarse-grained, this would not feel like sandpaper. This would actually feel like bumps on top of the rock. So these would be bigger than very small pieces you would only be able to see with a microscope. This is porphyritic texture. So this is just composed of two different types of rock. So you can see that in this rock there's these white pieces that are throughout, and then it kind of looks like a fine-grained texture everywhere else. And then this might be the type of igneous rock that you're more familiar with. This is igneous rock that feels glassy. This is forms when silica-rich rock, or I'm sorry, silica-rich magma solidifies. So if you've ever seen a glassy textured igneous rock, this is probably what you would have seen. And this is an interesting kind called vesicular igneous texture. So you can imagine if this was kind of like a sponge. Now this would not be, you would not be able to squeeze this because it's a rock, but if it's essentially the same thing. There's all these pores on the outside, and then they interconnect on the inside of the rock so that basically air was escaping through lava as it solidified. And this is pyroclastic igneous texture. So this is the consolidation of fragments that may include ash, blobs of magma, and anything else that's ejected during a volcanic eruption. So we'll learn more about pyroclastic rocks when we're doing the volcano chapter. All right, so basically igneous rock the classification is based upon the rock's texture and whatever the actual rock is made out of. So it really depends on the mineral composition. So another very confusing table, which I'm not going to make you memorize, so you really don't have to know this. Just know that there are different types of igneous rock, and we classify them based upon texture, and then depending on the temperature in which the rock is formed, that's when we'll start to classify these different rocks. So just another nice chart that kind of gives you some examples of those textures we mentioned: coarse grain, fine grain, porphyritic, glassy, vesicular, and pyroclastic. All right, so you probably know more about igneous rocks than you've ever thought you would want to know in your life. All right, just to end a few slides on igneous rocks. So there's a process to naming these things. Again, not going to make you worry about that, but just understand that based upon the mineral composition, you would have different names for these things. All right, we're up to sedimentary rock. So this is the type of rock that forms after igneous rock is weathered or some other process degrades it into a sediment. So this would be fine particles that could be collecting in rivers or falling down a mountain. Eventually, these things will layer on top of one another to form a sedimentary rock using this process called lithification. Now notice this second bullet here is important. About 75% of all rock outcrops are sedimentary rocks. So if you were to run across rocks, near your house, near the University of Scranton, they would most likely be sedimentary rock. And they're basically used to reconstruct much of Earth's history. So if you ever or were driving down a highway and looked on the side of a mountain that was carved out for the highway, you would see different layers of rock. And based upon those layers of rock, you would be able to tell the history of that specific location on Earth. And they're also important economically because this is the type of rock that you would that coal falls under. Petroleum natural gas pockets are found within sedimentary layers of rock. And it's also a great source of iron and aluminum. If you remember, they were one of the two elements that were rich in the Earth's crust. Okay, so classifying sedimentary rocks, thank God it's not as complicated as igneous. We basically have two groups based on the source of the material. We either have detrital or chemical. All right, detrital rocks. So these are the material has solid particles. It's also classified by size. And some common sedimentary rock that you are probably most familiar with would be shale, sandstone, and there's also conglomerate. So you can see these are some examples of different types of sedimentary rock based upon the particle size. So you have coarse all the way down to very fine. And sandstone, falls in the middle. All right, chemical sedimentary rock. These are derived from materials that were once in a solution and then precipitate out of that solution to form a sediment. Some common examples will be limestone, quartz, and coal. Again, here's just another table showing you some different examples of sedimentary rock. They're produced through lithification, so this is where loose sediments are transformed into solid rock. Essentially, this process happens by compaction and then cementation by calcite, silica, or iron oxide. Some other features would be strata or beds. So these bedding planes separate the strata. So when I mentioned about driving by a mountain on a highway that carved out that mountain, you would see these beds. You would be able to tell the different types of rock just based upon the different strata that you see. This is also where you would find some fossils, and I'm assuming you know what they are. They're basically the remains of some life that happened millions and millions of years ago. So a plant or an animal would fall, let's say, into a river, and it would maybe land on the bottom of the river, and then sediment would fall on top of that plant or creature, and then just over the years, the pressure of that would basically the fossil itself isn't actually the organic life form that was once there, but it's essentially rocks and sediment are replacing the void where that animal was. So essentially, if you were to cut up some shale, you would most likely see fern leaves or different types of fossils, very common to this area.